So here we taking the n number of conductors is there, and the current was passing through that conductor. We are assuming as a capital I. The flux produced we are assuming as a pi. So from that we have derived the relationship. That is a B is equals to pi by A, H is equals to B by mu naught into mu R. Then finally we determine the equation. Instead of B we can write as a pi by A. Then we are getting the equation H is equals to pi by A into mu naught into mu R ampere turns per meter. So then we define for the density or force, that is H is equals to Ni by L. So it is actually printed as a 1, but is a H is equals to Ni by L. So if you are simplify that, we are substituting H value. So H into L is equals to N into I. Instead of H, already we know the value pi by A into mu naught into mu R, that is equals to N into I. So R pi is equal to, we are getting the equation Ni by 1 by, instead of J, if we are taking as a J, A into mu naught into mu R. So that can be written as Ni is equal to, already we know that mmf. 1 by L by A into mu naught into mu R, that is we are called as a reluctance. So pi is equal to, we can write as a mmf by reluctance, that is ampere turns pi L by A into mu naught into mu R. So ampere turns equation pi into L by A into mu naught into mu R, that implies we are just separating the pi by A into L by mu naught into mu R. So already we know that pi by A is the B, is nothing but we are getting the equation as B into L by mu naught into mu R. So just we are separating B by mu naught into mu R. So already we know that H is equals to B into mu. So from that we can express the equation B by mu naught into mu R is equals to H. So ampere turns is equals to H into L. That is a formula we have discussed related to these two formulas. Means mmf formula we are using, at the same time ampere turns formula we are using. So we have solved two problems. So when a core material we are selected without air gap and with air gap. So that is a problems we discussed in the last class. So today it's the most important topic, that is a series magnetic circuit. So there are two types of circuits is available. One is a series magnetic circuit. Second one is a parallel magnetic circuit. So series magnetic circuit is nothing but already before previous class we discussed about the resistor. So you can see here the same concept will be we are using. So just we are assuming there are three different materials is available. So from here to here, this is a one material. From here to here, this is another material. From here to here, this is another material. The air gap also is provided. That is also air. Air we are assuming as a one of the material. So totally there are four materials is available. So each materials offers the resistance value is different. So the first material offers resistance 1 R1. Second material offers the resistance we are assuming as a R2. The third material is offers the resistance we are assuming as a R3. The air gap also having the resistance, that is we are assuming as a RG. So this is a equivalent diagram in terms of electrical. So here the resistance will be we are assuming as a reluctance, that is the value we are assuming as a S. But in electrical the opposition property will be we are assuming as a resistance. There is the same concept. So whatever we are using for the electrical concept, so the same things will be we are using for the magnetic circuits also, right? So here some assumptions we are taking. What are the assumptions is nothing but there are three materials is available. The air also we are assuming as another material. So because of that reason it is a constant. So sometimes we are taking the constant, sometimes we are taking as a unity. So reluctance is not a problem for air, but the rest of three things will be essential. So here we are taking three different metals or magnetic materials is combined together and the same flux is flowing through that. That is we are taking as an assumption. So here the material 1, 2, 3 having the cross section areas A1, A2, A3. And the relative permeability of each material we are assuming as a mu R1, mu R2, mu R3. Mu naught is constant for every material. So that is already we know that. Next we are assuming non-uniform current is flowing, but actually the current is same in series circuit. Instead of current we are taking the flux. So but what we are assuming here, from first material current is I1, from second material current is I2, from third material the current is I3. So next we are assuming the total current is I. So what we are taking here, I is equals to I1 is equals to I2 is equals to I3 is equals to Ig, because the same current is flowing through the series circuit. So already we know that concept. So series circuit concept already we know that. So these are the assumptions we have made here. So what are the assumptions we are taking here? So we are assuming there is n number of turns is available, and each cross section area of different materials we are assuming as a A1, A2, A3. Similarly, relative permeability values are mu R1, mu R2, mu R3. For air gap also we can assume mu Rg. So next, mu naught is common for all materials. So then we are taking the assumptions as a, from first material current is I1, from second material current is I2, from third material the current is I3, from fourth material is nothing but from the air the current we are assuming as a Ig. So similarly, the resistance also important concept, because the reluctance will be not constant for each material. So because of that reason, here one of the assumptions we are taking here, so we are assuming as S1, this is we are assuming as a S2, this is we are assuming as a S3. For example, we are assuming as a, this is for the air gap is a Hg, but Hg we are not, reluctance will be we are not considered for the air gap. So these are the assumptions we on S2, S3 are the reluctances of the three different sections in a magnetic circuit. Next, what we taking the assumption Sg for the reluctance in air gap. Next, lengths we are assuming as a L1, L2, L3 means so mean length. So from first material we are assuming as a length 1. So from here to here we are assuming as a length 2, L2. From third material, that is where it is also here considered. So that is we are assuming as a Lg. Next, cross is what cross section area is a A1, A2, A3 and Ag. A1, A2, A3 for three different materials. Ag is the cross section area of the air gap. Next, relative permeability. Relative permeability is denoted by means of mu R. So for three materials we are considering as a mu R1, R2, R3, and for air gap mu Rg. So here there is n number of turns is available. So the current is flowing through the magnetic material, that is we are assuming as a I. So here we are taking the same thing. So whatever we are considered for the electrical, so the same things will be we are applied for the magnetic circuit also. So how can we write here the equivalent resistance? So it is a three resistors are connected. So totally four resistors are connected in series. So then R total is equals to R1 plus R2 plus R3 plus Rg. Rg is a fourth. So this is a equivalent resistance we are find out to simplify the circuit. So for example, we want to determine the current value. So already we know that I is equal to V by R. So sometimes instead of E is given as a E value also. For example, in this circuit, E is a 10 volts and resistance value is given as a 1, 1, 1, and Rg also offers the 1. Next, what we want to find out the current value. Already we know that. So the equivalent circuit is becomes one single resistance in series with the load. So then only easy to possible to determine. This is becomes RT. So this is a V value. So we can easily find out I is equal to V by R total. So the same concept also we are applied for the magnetic circuit. So in here we are find out the flux value in magnetic circuits. So, but in case of electrical circuit, the quantities of current or voltage or sometimes missing resistance will be we are find out. So the same concept also we are applied for the magnetic circuits also. So first we take the assumptions, all these things. Each resistance is nothing but magnetic circuit. The resistance will be we are called as a reluctance. Each reluctance is a S1, S2, S3 and SG. Mean lengths of three materials and air gap is a L1, L2, L3 and LG. Cross section area of each material, because three materials does not have the same cross section area. Each and everything will be having different cross sectional areas. That is A1, A2, A3 and AG. Relative permeability also different, because those four are the different metals. So that is a mu R1, mu R2, mu R3 and mu Rg. So next N is the number of turns, I is the current flowing through the N turns. So that is will be we are considered. So to calculate the flux value, first we find out the total reluctance value. So total reluctance, how can we calculate? Whatever the formula used for resistance, the same concept also we are used. So what is the thing? S is equals to S1 plus S2 plus S3 plus SG also. So here one term is missing in the expression, but S is equals to S1 plus S2 plus S3 plus SG. So first we substitute the S1 value. So already we are derived in the previous equation the reluctance value. The reluctance value is nothing but L by A into mu naught into mu R. That is the reluctance formula. So here the same formula we are applied here. So what is the formula is here? L1 instead of L we are taking as L1 by A into mu naught into mu R. That is the formula. So instead of A we are taking as a A1. Instead of mu R1 we are taking as a mu R1. So similarly for the all quantities we are applied. So then what will be you are getting the equation S is equals to L1 by mu naught mu R1 A1 plus L2 by mu naught mu R2 A2 plus L3 by mu naught mu R3 into A3 plus LG by mu naught mu Rg Ag. So this is the reluctance value we are find out for total three materials with air gap also. But already we know that the total EMF. So how can we derive the formula is nothing but, so flux is equals to what we can write the formula? MMF by reluctance. Just we reverse the formula because we don't know the flux value, MMF value. So for example, if you want to find out the MMF value, so the formula we can utilize it. So pi is equals to MMF by reluctance. So that formula can be changed as a total MMF is equals to flux into total reluctance. So flux is a pi, total reluctance is a S. So then we substitute the values of pi and S in this formula. So pi S is nothing but, instead of S we can write as a S1 plus S2 plus S3 plus SG. So then we are substituting the S1 value, S2 value and S3 value. So if you are substituting S1, S2, S3 values, then the equation is becomes pi of L1 by mu naught into mu R1 A1 plus L2 by mu naught mu R2 A2 plus L3 by mu naught mu R3 A3 plus LG by mu naught mu Rg Ag. So already we know that if we are multiply pi in this equation, so how can we get the equation? If the equation is becomes, so pi into L1 numerator below, pi into L2, pi into L3, pi into LG. So then what we do the next step? Just we are separating the terms of pi by A in a separate manner. So how can we separate? So simply, so we can see here pi by A1 into L1 by mu naught into mu R. So this type of formula can be we are applied here. So then how can it will be the equation is becomes pi by A1 into L1 by mu naught into mu R plus pi by A2 L2 by mu naught into mu R2. Similarly, pi by A3 into L3 by mu naught into mu R3 plus pi by AG into LG by mu naught into mu RG into AG. So that is the next step. So already we know that pi by A is equals to B. But here A1 is there. Because of that reason, so just we are getting the term as a B1 into L1 by mu naught into mu R1 plus B2 into L2 by mu naught into mu R2 plus B3 into L3 by mu naught into mu R3 plus BG into LG by mu naught into mu RG. Here mu RG we are substituting the value as a 1 because it is a air. So next, already we know that, so the equation is becomes B1. So L by mu naught into mu R can be written as a H. So how can we get? So this is a formula, right? So from here, so we can simply write as a B by mu naught into mu R. So that can be substitute as a H value. So then what is the equation we getting here? So instead of B by mu naught into mu R1, so this term will be we are used. So this term is becomes H. So H1 into L1 plus H2 into L2 plus H3 into L3 plus Hg into L3. So that is a equation we are getting finally. So is nothing but the total MMF is equals to MMF of 1, 2, 3 and air gap. So in ampere terms, so it can be represented as ampere turn 1 plus ampere turn 2 plus ampere turns 3 plus ampere turns G. So last class lo chesinaటువంటి problem kuda ade. So we are taking a simple core. So at that time only we are calculating 1 ampere turn only. Ampere turn is equal to N into I, that is the formula, already we know that. So that is equivalent to the MMF produced by means of that material. So that is we are equivalent to the same things. So similarly, whenever air gap is placed, we are calculating 2 ampere turns, 2 MMFs is nothing but MMF1 and MMFG we are calculating because there is only one core material is there, then and air gap also provided. So because of that reason, so there we are calculating the 2. For example, only 2 materials with air gap is there, then we are calculating 2 MMFs for cores as well as 1 air gap also we are provided. So similarly, there are 3 materials, 3 different materials is combined, then we are calculating 3. If there is no air gap, only we are calculating the 3. But for example, if there is a air gap is provided, we are calculating for the 4 MMFs. If there is a 4 metals and with air gap, then calculation is becomes 5. There is a 6 materials with air gap, there 7 calculations will be needed. But most of the cases examination is limited for the 3 different types of materials combined as a series manner. So up to that range only I may be asked the questions. So this is the formulas you want to remember. This is for the series connection. So whatever it may be, the basic formulas will be essential. First we know that, for example, is mentioned the S value. So then we are calculating S1, S2, S3. For example, SG also is present. So we are calculating and substituting the values in the final equation. So then we can simplify the MMF value to determine for a given problem. So those are the series connection. So in case of series connection, so in this diagram, we are taking 3 dissimilar materials, 3 dissimilar magnetic materials